A 2.38 kilogram projectile is fired with a velocity of 187 meters per second at an angle of 22.7 degrees above the horizontal. What will be the momentum of this projectile at the highest point of its trajectory? So, if we were to draw a diagram of this projectile in action, we would see its trajectory would look something like this, where at its highest point, its vertical velocity is 0, but its horizontal velocity is the same as it is throughout this system. So at this point, the horizontal velocity is equal to the horizontal velocity at the start, which means if we use directions in order to, or if we find the vector, the horizontal vector of this velocity we're given, we can find the horizontal velocity, or the only velocity we need to find the velocity, the total velocity at this point. And since we'd have the total velocity, we could just multiply that by the mass, and we'd get the momentum, which is what we're searching for. So let's look at our data. We have that the projectile is 2.38 kilograms. That's the mass. It is fired at 187 meters per second. And that's the velocity, but it's not the velocity we're looking for specifically. And we have that the angle of the velocity is at 22.7 degrees. So this part here would be 22.7 degrees. Okay. So then we're searching for the momentum. Okay. So first, let's draw a wonderful triangle. Okay. It should be a right triangle. Let's try that again. Okay, and let's say that its angle here is 22.7 degrees. So the horizontal, it's 22.7 degrees above the horizontal. This would be the horizontal. Okay, and its hypotenuse is 187 meters per second. So what we're searching for is this, the velocity in the x direction. So using trig, you can say cosine of 22.7 degrees equals Vx over 187, because that's adjacent over hypotenuse, and you get the Vx is about equal to 172.5. Again, I use the exact value, but you can use 172.5 and you won't be too far off. So now we have, and that's the only piece of information that we needed in order to find what we're looking for. So we use velocity, the horizontal velocity, and the mass to calculate the momentum. So P equals mv. So P, let's work this out, which is step 3. Momentum equals 2.38 kilograms times around 172.5 meters per second, if you can read that. And you get around 410.584802 kilograms times meters per second, or you can just say 411. Now, so, yep, and that's our answer. Again, you can probably say 411. we're not. Okay, kilograms time. Okay, that's an abomination right there. But yeah, that is the answer. Can we justify this? Yes, we can say yes, this makes sense as it's reasonable given the data. So yeah, that is FRQ number 6.